everything which I told can be felt on a concrete example. So, for example, we see something that we discussed. Okay, that there is a test called get hello message should return expected message, and there is implementation. But okay, what if I want this to do something else? Let's say I want my code to work as a calculator. So let's say, and now we are making something which somebody would call three amigos sessions, where I, before thinking how I'm going to implement the code, thinking how I'm going to use this. And it's actually a design session using tests. I'm going to rename this and call it, for example, this convention that I'm going to use for naming called should. And the idea is that the tests, unit tests, also actually acts as a specification. And let's say I'm going to see that there is a method which is called calculate. And this method should return me a sum of two numbers. Calculate should return sum of two numbers. Good. So let's say that I want to sum expected result going to be 3, right? And when I'm going to call calculate and give this number 1 and number 3 and the operation plus, and assert that the result equals. Okay, you see that I already see an error, and that's what is expected because there is no method called calculate that would take those 3 parameters. So what I'm going to do, there is no point in running tests here, it won't compile, and that's also considered failing. That's all right. What I'm going to do, I'm going to go to main and add here a method called calculate, which takes in 2 parameters and 1 string and returns 3. All right. Okay. Now I'm running the test. The test is going to pass, but that's not what I want. It actually has passed, I believe. Okay, first test results. Should have been some. When I usually run the test, it marks that it passed here, but it usually opens a window. Okay, here it is. Yeah, Java test report, it has passed. All right. Going to move it like this. But that's not what we wanted, right? Well, first of all, I have noticed that I haven't provided meaningful results at all, and it has passed. So that indicates that the code is not doing what I wanted to do. And for example, if I change expected result to something, it's going to fail. So that was the first loop of test-driven development. And then usually what happens in real life, someone would add another test or make this test a parameterized test. We will have another test and suggests that for 1 and 3, it should return a different result. I'm going to run this, and that's going to fail. Okay, now it looks like I'm doing something weird. Why didn't I implement the sum function the way it should have been implemented from the start? Because I knew that returning 3 was not the right thing to do. I did this to demonstrate how it should be done in a classic TDD. And the idea behind that is that in order to avoid unnecessary complication of code, if there is no test failing, we don't add other unnecessary code. For simple cases like calculator is, it doesn't make sense. It makes lots of sense for complex scenarios. But never mind, let's go to the calculator implementation. And here what I'm going to do, I'm going to move this here, and okay, it doesn't let me do this. Got it? Oh, okay, nice. So on the left, we have tests. On the right, we have code to implement, and that's how usually test-driven development is done. So you see both the test and the code. Good. What I need to change here to fix this? And the proper answer is that A plus B. And then I'm going to run the tests. And you have, yes, they're passing. Why shouldn't they? All right. We notice here that I, while designing this, have considered that I provide a plus here, because what I wanted my calculator to do is to be a real calculator and also be able to do things like subtracting and multiplying, things like that. So I'm going to add another test. It's going to be, should return, okay, result for subtraction of two numbers. And yes, so here expected results are going to be, let it be 4 as well, and like 5 minus, oh no, 4 minus 0, just why not? And the operation should be minus. I can run the test and see that it's not going to pass, because, well, there is no code that supports it. Oh, no, that was stupid. It is passing because for 0, it's going to be the same result is going to be for sum as well. Okay, now we see it's failing. Good. And the other benefit of running tests on this atomicity is that I don't need to think what is failing. I know exactly what is failing because I know what I have just changed. And what I'm going to add here is it's going to be simple if s equals minus, then return a minus b, and run the test. It's going to pass. Similarly, I can add division, multiplication, and my code is going to evolve. So, well, let's just do this. It's going to be very simple. And important part here is that when I do this, when I write test first, I am concentrating on the test. So, I mean, test must be clean. The code can be dirty, and that's all right, because if my tests are okay, then I can refactor the code. Okay, multiply. So it should be 2 and 2, and and it's going to fail, then I add else if as equals multiply, then turn A multiplying B is going to pass. It passes. And similarly, I add subtraction. Like it takes me a couple of seconds to do. So, oh, sorry, division. So I will just do this. All right. And that's going to be like this. It's going to fail. Right? Else if as equals then turn A. Done. The implementation is complete. Now I have a test for this already. I can refactor the code if I want. And for example, don't use if here, use case, but the core implementation is already done. It actually can be shipped without much of a problem. That's it for test-driven development.